third method for rounding edges is with 3DCoat. So this method is a little bit more elaborate as it involves mesh smoothing in another 3D program called 3DCoat. When exporting CAD data from Rhino or Matrix to mesh, it tends to make a mess of triangles instead of quads. So working with meshes is completely different than what we've been used to in modeling with NURBS. I'm not going to go into detail how to make good meshes, but it does involve having properly made NURBS surfaces, and also if you can, you should tend to have quads in your mesh. And if possible, you need to have those quads oriented in a proper way. The pros and cons for this method is, for the pros, it's fairly fast, it's fairly easy, it gives you good quality. And for the cons, occasional surface imperfections, like you can see on this cube on the side and on the top. Another con is autopo, which is the final step of this method, often fails because autopo is actually redoing the topology of your mesh. And sometimes it's hard for it to calculate all the small details. And this is why occasionally you have open meshes as well. And another con for this method is you are not able to set the exact radius of rounded edges. So you would have to round the edges in Rhino with fillet edge and then smooth out that in 3DCoat. Okay, over here I have a pretty simple model of a 3-stone ring. It has been modeled with rounded edges already. But you can see there are no rounded edges between the separate objects, like this one, and this one. So let's hide the gem layers so we can work with only our metal objects. And let's try first to Boolean union this. Let's select everything and type in BU for Boolean union. And now we see that Boolean union failed. This is not very uncommon in Rhino, and usually there's a very good reason why this happens. In this case, it happened because we have two surfaces laying in the same plane. They are like overlapping, and it's hard for Rhino to calculate that. But for this exercise, this is not important, as I will be showing you as well how to join all these together in 3DCoat. So it will automatically be joined, so you don't need to have any object booleaned. And as you can see, even this object has an open edge. But it's always good to try Boolean first in Matrix, because the operation in 3DCoat can fail sometimes as well. So let's select all objects and create mesh objects for the output. We're gonna do that by typing in the mesh command and hitting enter. I often use these settings for this purpose, so you can set everything to 0 except minimum edge length and maximum distance edge to surface. You can put that to 0.001 and leave refine mesh option on. So let's go ahead and click OK. When we move the NURBS surfaces out of the way, we see the mesh structure as good as it can get in Rhino. The orientation of quads is pretty nice, and there are triangles here and there, but that is fine. Select all the meshes and go to export. We will save it under a name of 1 for the file name, and for the type we need to select the OBJ. As for the OBJ export options, these are the settings I usually use. If you have some open object, it is good to select welded, as it will keep the surfaces together. Make sure the map Rhino Z to OBJ Y is selected. Now let's open 3DCoat. To import your OBJ file, go to File, Import, and click on Import Mesh for Voxelization, and select your file. Once the file is loaded, you will see this number, which represents estimate poly count. We need much more polygons, so we will be scaling up the whole ring by 5000. To do that, we need to click on the little scale cube in the middle of our object and press space. Now we can input 5000 as a scale number. Now the object has around 5 million polygons, and this is something we can work with. It depends on the complexity of your models, how much polygons you need to work with. I find 5000 times scale works in 99% of the time for me. Click Apply to confirm. Select Smooth Operation from Vexel Tools Rollout, and with this we can manually smooth out certain parts of our model. But we will use an automatic way of smoothing out the whole ring first. First of all, we will inspect the mesh density. By pressing W on keyboard, we will turn on the wire display. We can see that we can reduce this density to much less number. We can reduce it by clicking on the Resample button and setting the required poly count to something around 1 million. Let's go and click on Smooth All buttons 2 or 3 times, depending on how strong the smoothness of the edges you like. Now we can manually smooth out some areas more by just rubbing out the part of the model you want smooth out. But to do that symmetrically on all sides of this ring, we will turn on Symmetry by pressing S key on your keyboard and selecting the X and Z axis. Now you can see when you move your mouse cursor on one side, it actually mirrors the same cursor along the X and Z axis, smoothing out all 4 sides. You can decrease the smoothing strength from 80% to 30% if you want less power on your smoothing tool. I will be smoothing out more on the inside of the ring, as this is usually where the polishing is most pronounced, as it needs to be very smooth for the comfort of the finger. When done, you can export this to a new OBJ file by going to File, Export, and clicking on Export Projected Quads. You can save this file over your first OBJ, but I like to save it under separate files so I can easily go back step by step if things don't go as planned. Now let's create a new file by clicking on File, New. Now we will use automatic retopology of 3DCoat to make our OBJ file more optimized and to reduce any bumps on the surfaces. Please note, this method tends to fail pretty often, especially on more complex models, but it is worth a try as it will bring a bit smoother surface to your mesh. If for some reason Autopo fails for you, you will need to go back and forth and play with different mesh settings in Rhino and also voxelization settings in 3DCoat until you get it to work. If you find yourself spending a lot of time making it work, either use the mesh without Autopo or try a different way of smoothing out the edges I explained here in this course. It is the trial and error you need to go through until you get the results you want. Okay, so let's go ahead and go to File, Import, and click on Import for Autopo. Select your OBJ file and in the Autopo parameters window, set the required poly count to something about 100,000. Again, this depends on your model. Sometimes it can go lower, sometimes it needs a bit more than that. You want to have as little as possible, but still not lose mesh definition. As for other options, leave them as they are. Put the best quality, 50% for capture details, auto density leave it at 1, decimate model 40, and keep sharp details turned on. And press OK to confirm. Here, you can paint on the parts you wish to have more density, like on sharper edges or crevices. We will not use this now, so just press next. In this step, you can turn on symmetry by pressing S key on your keyboard, just like before, because sometimes this can help if Autopo fails. Press next and be patient, sometimes this can take quite a while. So I will speed this up 10 times. Once the Autopo is finished, you will have a pretty nice model with mostly nice quad mesh topology. So let's go ahead and export this file by clicking on File, Export Retopo Object. Again, I like to make this a separate file in case I need to go back and do Autopo again. So let's go ahead and call it number 3 and click Save. Now we need to import this object in Matrix by going to File, Import, and select the number 3 and click Open. For the settings, I use default matrix settings for this. Make sure the map OBJ-Y to Rhino Z is turned on though. Click OK. Straight away, you see the ring is huge. That is because we scale it up in 3DCoat and now we need to scale it down. So let's go ahead and start the scale command. And for this origin point, set 0. And for the scale factor, let's use 0.02. Let's zoom in on the object and move it away so we can compare the two. If we turn on the rendered view, we will see there are no sharp edges anymore. And everything is smooth and the mesh is optimized fairly well. To inspect the model further, we will use Zebra. To see how the reflection will look, and although we can see some imperfections, once we load this model in KeyShot and add materials, it will look even better. Let's go ahead and bring back the gem layers and move back this mesh surface to its position and isolate only the new mesh and the gems. The only part that's left for us to do is to make the pre-cuts for the stones. So we can do that in two ways, by using gem cutter or by using offset surface. First, we'll try the gem cutter. The best gem cutter to use for this is this one, shallow. So make sure the gem cutter is not intersecting the stone too much. And now, using mesh boolean difference, we will cut the metal part. If you want these cutouts to have smoothed edges, then you need to make the pre-cuts for the stones before you do the smoothing in 3DCoat. For the two side stones, we will use the offset surface method. So let's go ahead and type in offset srf and select the stone that we wish to offset. And let's use for the distance 0.03 millimeters. If we turn on the shaded view, it will be easier for us to see what happened. So straight away we can see there are two stones now, one smaller with sharp edges and the other one bigger with rounded edges. And now we can use mesh boolean difference again to cut the metal part with this gem. We don't want our gems to intersect the metal object. If we undo the mesh boolean, now that we know that the mesh boolean works, we can mirror this to the other side. Now we can do the mesh boolean difference on both sides. Let's go ahead and turn on the gem layer again, and now we have a ready model for rendering.